Hello, welcome. This is 3.7. We're going to talk about we're going to take some notes on solving equations for different variables. Yeah, so now we can solve for x, but our answer is not going to be a number. It's not going to be x equals 5. It's going to be x equals some other relationships with other variables. Because we're going to see more than one variable, more than one unique variable letter in these equations. So the content of this page is that you are given an equation or formula with more than one variable, and you're being asked to isolate one of those variables. They'll specify which one they want by itself. You'll never lose a variable. So if there's an A, a B, and a C in an equation, your answer will probably have an A, a B, and a C in it. And we're going to manipulate or undo the pieces of the equation using inverse operations, just like we've been doing. So a formula is just an algebraic equation that relates two or more real-life quantities. Can you think of one? How about the area of a rectangle is length times width. You got the area of a triangle, so that's of a rectangle. Area of a triangle is what, like your base times height divided by 2. Oh, how about distance equals speed times time? So what if we took a look at, let's do distance equals speed times time. So what if we tried to isolate the s, or get s by itself? So we'd ask ourselves the question, what side is s on? It's on the right. What's being done to it? It's being multiplied by t. So then how do we undo multiplying by t? We divide by t. So we get s. Hey, we've got s by itself. All right, s equals distance divided by time. We can write it with s on the left side, so we've isolated our variable and put it on the left. And that's a true statement. Distance equals speed times time. If I knew my speed and I knew my time, if I was going 60 miles an hour and I traveled for 4 hours, speed times time, 60 miles an hour times 4 miles gives you my distance. If I know my distance and my time, if I know I traveled 300 miles, that's a distance. In 2 hours, I'd know my speed. I was going 150 miles an hour. I was on an airplane. A slow airplane? Anyway, so we can rearrange these formulas so we can easily calculate what we want to calculate. Whether we want to calculate the speed, which is what your speedometer is doing quickly, or if we want to know the distance, we could even solve this variable for t. All right, so that's what we're looking at. So function form, a two-variable equation with one of its variables isolated on one side of the equal sign. Y is a function of x means that the y is isolated. And you've seen this a lot before. Y equals mx plus b. Have you heard of that equation before? There, y is a function of x. Remember, y is means y equals. So the y is isolated. Whereas x is a function of y means that x is isolated. So it would be x equals yada, yada, yada. Now here the directions say rewrite so y is a function of x. Rewrite so y equals. In other words, get y by itself. So you're going to ask yourself, what's being done to y? Y is being added by 9x. We need to get rid of the 9 and the x. That's a clump. That's a unit right there. The 9x is together. So how do we undo a positive 9x? We subtract a 9x, like we've been doing the last couple days. 9x, take away 9x is nothing, so we're just left with a y. Now on the right side it says 4 minus 9x. We cannot combine those two things. One's a constant and one's a variable. So we just need to write those down. Now you could write down 4 minus 9x. I'm going to encourage you to write your variable first. So let's go negative 9x and then write that down the constant. Now be careful, is that 4 positive or negative? It's a positive 4. So it's the 9x that's negative, so negative 9x, and then plus, there's a 4. Negative 9x plus 4. Let's keep solving for y here. Now when you ask yourself what side of the equation is on, you say it's on the left. The y is on the left. What's being done to it? There's a bunch of stuff. There's a bunch of stuff you're going to have to undo in this one, folks. You could say, well, y is being subtracted by 6. Or y is being added by 2x. Or y is being multiplied by 3. Now here's the deal. Remember when we undo things backwards. It's like we're investigating, we're being a detective, so we need to work backwards according to what happened. We need to do PEMDAS or undo PEMDAS from the bottom to the top. So you have to undo addition and subtraction first. Now honestly, folks, it doesn't matter whether you want to do this first, undo that first, or undo the adding first. You can undo the subtraction or the addition first. It's up to you, but you can't undo the multiplication first. It's a no-no. That'll lead you down the wrong path and you'll get the wrong answer. So I'm just going to add 6 first. What I do to one side, I do to the other. So now I have 2x plus 3y equals 15. So next step, I'm going to undo adding 2x by subtracting 2x. So this is gone. On the left side, I'm left with 3y. Now on the right side, I'm going to choose to write the variable first again. And you'll see why. You'll use this in the future, and you'll thank yourself for writing the x's first and the constant second. So it's a negative 2x that gets written down first, and then it's a positive 15. And then last but not least, divide by 3. Now over here, I could make one big division sign. Now that's also the same as dividing each thing by 3. So I could say negative 2x divided by 3, and I could say 15 divided by 3, which is 5. I'm going to ask you to please do this. Please divide each thing respectively on the right side by that value. Sometimes they can simplify, like 15 divided by 3 being 5. Sometimes they can't, but please try. All right, last 2. Here, y is being subtracted by 16 and multiplied by 2. So I'm going to undo subtracting 16 first by adding 16. So I get negative 4x plus 16 equals 2y. And then divide by 2. Divide everything by 2. So we get negative 2x plus 8 equals y. Now, let's put what we isolated on the left. So y equals negative 2x plus 8. Boom. Last but not least. Whoa, hello. Hello. That was a del, but it didn't sound like a del, did it? Oh, man. Alrighty. What's being done to the y here? This one is tricky because of the subtraction sign. I'd recommend that you think of this as 2 plus negative y. So what's being done to y? It's being multiplied by negative 1. It's like there's an invisible multiplier of negative 1 here. I'm going to just rewrite this real quick. It's worth it to understand that this line that was typed plus negative y is the same as 2 plus negative 1 times y equals 8x. So what's being done to y? It's being multiplied by negative 1, and it's being added to by 2. We need to undo the adding by 2 first, so we'll subtract 2. So we get negative 1y equals, what should I put first here? Please try to put the x's first. It's not wrong to write it the opposite way, but the 8x would be better to go first. So it's 8x. The 8x is positive, the 2 is negative. So 8x minus 2. Last but not least, y is being multiplied by negative 1, so let's divide by negative 1. Everything gets divided by negative 1. So we get positive y equals, now we're dividing by a 1, which doesn't really change anything, but it's a negative 1. So a positive divided by a negative is a negative. So it's negative 8x. And then here, think of that as a negative 2. Right? I changed the subtraction sign to adding the opposite. You know what? I should do that in opposite color so you guys aren't like thinking I'm trying to do magic here. So it was subtract 2. Let's go plus negative 2. So I'm going to drop down this plus sign right here. And we have negative 2 divided by negative 1. That's a positive 2. Boom. you might find these a little bit abstract, a little bit like, what's going on? That's crazy. Next chapter, we'll kind of bring things together. You'll see why you're doing this skill. You'll like doing this skill. Last year, a lot of students, for a skill that we need to do in the future, preferred being able to do this, to do that future skill of graphing. Alrighty, so hang in there if you're getting stuck.